So guys, in this video, we are going to perform the cross validation with respect to lasso regression model. And I've already told you that how we can perform it. We will be using lasso CV. Now let's do one thing quickly is that let's try to create the specific lasso CV is equal to this. And let's go ahead and see some of the information inside this lasso CV. So if you probably see this lasso linear model, it is with iterative fitting along a regularization path. So it will try to play with all these parameters and try to select the most suitable parameters over here. Now, even to select the epsilon value, the alpha value, it is going to check with respect to different values, and with respect to that we are going to get some output. There's also, if you probably go and see each and every parameters, please make sure that it is very much necessary, guys. You have to see each and every parameter, right? What this specific parameter is useful for. So here you can see number of alphas along the regularization path, list of alphas, where to compute the models, normalize, p compute, max iteration. So all these practices, right? And there is also one important parameter which is called a CV. This basically indicates that how many number of time cross validation you want to do. And this can be an integer value. If it is an integer value, you have to basically you're specifying that how many number of k folds you're going to happen. If you just specify CV is equal to none, it is basically going to take by default 5-fold cross validation, right? So by default 5 folds, and other than that, whatever value you want, you can basically put up, right? And n underscore jobs is there. This we have already learned it. This selection is an important parameter. If set to random, a random coefficient is updated every iteration rather than looping over features sequentially by default, right? So again, out of this two, you can basically select any one, right? What this entire class is going to give you, it is going to give you alpha value. Why this alpha value is there? This is nothing but the amount of penalization chosen by the cross validation. Because if you see over here, if I just press shift type, here the first parameter is alpha, and we have to select one alpha value, right? And this will basically happen with the help of cross validation. So let me just show you more parameters that it is going to give back. So you also have coefficients. Obviously coefficients are there, intercept is there, MAC path. This basically says mean squared error for the test set on each fold varying alpha. See, the number of alphas that are getting selected over here are 100, right? 100 alphas. You're going to try with 100 alphas. So for every test data or test data set, it is going to play with this 100 parameters, and it is going to select the right value, the value that can give the highest accuracy. So that is the reason why it is written as MAC path, and we'll be able to see this also. Alphas, the grid of alphas used for fitting, what all alphas were initialized, that all will be also available over here. So let's go ahead and let's quickly implement this. By default right now, I'm just going to make sure that I'll write CV is equal to 5, and then I will say lasso CV dot fit on my X train scaled comma Y train. Okay, so let's go ahead and execute it. So here I have actually got it. Now you can also use this lasso to predict also. Like to predict also, you will be able to use it. Now probably if I give my X test underscore scaled, here is what is your prediction output, you are able to get it, right? So I hope I have also done the prediction for X test, right? So perfectly, you are able to see all the predictions clearly. Now let's have a look on all the parameters that we really wanted. What alpha value it got selected. So if I write underscore alpha, right, this is the alpha value it got selected after doing such number of iterations, right? If you want to see what all alpha value it basically tried on, right, you can basically write this alphas underscore. So this is all alpha values it has basically tried on, right? And this total number of values will be mostly 100, right? So 100 alphas, because that number of alphas we had initialized, right? So this was about alphas, right? And if you want some more parameters, let's see, lasso CV dot, if you see some more, right? Let's see what all things are there. Set params is there, predict is there, positive is there, MAC path. Now this, just imagine guys, this probably will be 100 iteration, 100 alphas we are playing, and we are given 5 cross validation. So total number of MACs that may get calculated will be 500. So here you can probably count this. It is somewhere around 500, definitely, I guess, because the number of iterations is that much itself, right? Now here you can see with respect to each and every path, what was the mean squared error also, that value also you are able to get it, right? So now you can basically use this also for doing the prediction with respect to our test and this. But one thing that you really want to do is that, let's say if I do the prediction, okay, we can also check the accuracy, how good the accuracy is, right? So let me go ahead and do the, so here I'm just going to write y underscore pred is equal to lasso cv dot predict on my x-train scale data, and here I'll just say plt dot scatter on my y pred comma, sorry, y test comma y test comma y pred. And this is one of the way just to find out, okay, I'm getting some error, x must y must be same size, x train, okay, sorry, it should be x test, right? It's okay, we will do this kind of mistakes. Now here you can see, you can find out a good linear relationship. If you also want to compute the R2 score and the other score also, you can also do this, right? I'm just going to copy this entire thing and paste it over here, right? And just try it from your side also, guys. This is super important. Now here you can see I'm getting R2 score somewhere, mean absolute error this much, a good result in short. Now similarly, what we can do with respect to ridge regression also, we have some ridge regression CV model also. So from sklearn.linear model, I'm going to import ridge CV, right? So this part also we can basically use it. Now quickly let me just write it down and then we'll try to see all the parameters. Ridge CV, right? Press shift tab, and here you can see that again here also different ways alphas are selected, right? So ridge regression with built-in cross validation. This is also specifically used for cross validation. By default, it performs generalized cross validation, which is a form of efficient leave one out cross validation. So here, if I don't provide cross validation any value, it is just going to use leave one out of cross validation. That basically means if I say CV is equal to none, then what it is going to do, it is going to take one as a training data set for the, one as a test data set for the first experiment and remaining all in the training data set. In the second experiment, the next second record, only one record it will be taking in the test data set, and remaining all it will be put up in the training data set, right? So alphas is also here, normalized scoring parameter cross validation. This value also you can basically select and you can find out, okay? So here what I'm going to do, by default I'm going to give cross validation is equal to 5, and then ridge CV dot fit on my x train scaled comma y train, okay? And I'm going to copy the same thing over here. Let's see, just to check how things are coming up, okay? Plot dot scatter y pred, okay, I'm just going to do this and dot predict on my x test data, and this will basically be my y pred. I hope it will work fine and we will be getting a good error. Now here also I have to do x test scale, okay? That is the reason why we are getting. So here also you can see that we are getting a good accuracy, 98%, 56 is the mean absolute error, which is good. And yes, with the help of ridge CV also we are able to do cross validation. Now here also, if you probably go and see, now here the first parameter that you saw alphas, it is going to take a range between 0 to 1, and it can take 10 numbers. It can play with 10 numbers, right? That is what it says. See, ND array of SEP and alphas, comma, this default is 0.1, 1.0, 10.0 array of alpha values to try, right? So here, if I probably go and see ridge CV dot alphas, here you will be seeing that it 1.0 got selected. If you want to see how many number of alphas were there, these all were the different alphas that it tried it out, and definitely out of this it is basically selecting one, okay? And apart from this, the other parameter also, whatever you want, like best score, GVC mode, right? What all mode it is basically used at, right? Then dot get params. With the help of get params, you'll be able to see all the params it has basically used. GVC mode is none. This arrays, this has been selected, and all the information is there, right? So similarly, finally, you can also do with elastic net. And again, I'm just going to copy this entire thing, paste it over here, and try it with elastic net CV. And here, elastic net CV. Okay. And this will be elastic CV. I'm just going to name it. So this is how we can basically perform elastic CV. Okay. This is how you can basically perform all these things, guys. And here also you are able to get a good accuracy. In short, you have done cross validation. Now, one important feature with respect to elastic net, right? Here you have something called as L1 ratio. By default, it is 0.5. That basically means on the L1 norm, this model needs to focus on 50%. On the L2 norm, it should focus on the other 50%. And again, other parameters are almost same, like n underscore alphas and all. So here you can basically see selection process is also same, right? Now, if you probably want to check elastic CV dot alphas, you will be able to see this. This is the alpha it has got selected. Total number of alphas underscore I'll be using. So these are all the alphas we have played with, all the 100 alphas, and based on that you can get it. So in short, I have discussed about cross validation with respect to all the algorithms. I hope I have understood this video. This was about ridge, elastic net, and lasso regression, and I have also showed you with the help of cross validation. Yes, this was it. I will see you all in the next video.